Bless you. So we've got a couple of equations up here. And I don't see any square roots. So I wonder what is happening. So we were asked to solve here. When it says solve, what that means is get to where it has an x equals. So solve means our goal is to get x equals something. That's what the goal of solve is. So on this first one, what can I do to try and get the x by itself? We're not going to want to multiply it out. You could multiply it, but you're actually going to make your work a lot harder. It's doable. I don't know that it would refactor. You'd then have to use a quadratic formula, which is gross. But you could do it that way. If I want to get the x by itself, what can I do to both sides to get rid of a square root? Square root it. Yeah. We just kind of like half answered each other's questions because I said it wrong too. How do we get rid of a square is we can square root it. So we have the square root and the square canceling out, and we're left with x plus 2 equals 5. When we were solving these way back in the day, remember it could be positive 5 or it could be negative 5, and we don't know. Bless you. Whenever we square root both sides of something, when we were solving, we had to put both options. Because it could have been that when this guy got squared, it was positive, or it could have been that this guy, when it was squared, was negative 5. So then we're going to split it into our two options, where we had x plus 2 could be 5, or we could have x plus 2 being minus 5. And what do I do to each of these to get the x by itself? Subtract 2 on all the pieces. So we have x equals 3, and we have x equals negative 7. This one has two solutions. And when we have squares, we're often going to have two solutions. When we square root something on both sides, we've got to do the plus or minus. But that's like a last semester thing. But then I'll come back. On the right-hand side, this was our absolute value stuff, and we're going to treat it very, very similarly. We're going to get our absolute value by itself. We're isolating. Then we're going to split it into its two options, and then we'll solve. So our first step is to isolate the absolute value. Wait, okay, that's right. It looks wrong. If I want to isolate the absolute value, what do we need to do? Subtract 2. I want the bars by themselves, my little tiny jail cell. And if the absolute value of the x minus 3 equals 4, that means this chunk, maybe that chunk equals 4, and my absolute value bars aren't doing anything. Or maybe that chunk, x minus 3, actually equals negative 4, and the absolute value bars are working. So we isolated, we split it into our possible cases, and now we're going to finish solving. Because what do I need to do to finish solving it on this one? Add 3. Add 3. And we get that x could be 7. And on the other one, we add 3. We add 3. And we could have that x equals negative 1. And if we go back in to double check on our original equation, if we substitute in 7 here, 7 minus 3 will be 4. Absolute value of 4 is 4 plus 2 gives us 6. So you can substitute it back in to check. Same thing over here. We could substitute in 3. 3 plus 2 is 5. 5 squared is 25. Negative 7 plus 2 is negative 5 squared gives us 25. So you can plug them back in and test them. Okay? So we've been doing solving kind of all year. I wonder what we're doing with our square roots today. Oh my gosh. We're going to solve. Okay, so we're going to be finding x equals in our square root equations today and tomorrow. That's the last thing in this chapter. Okie dokie. So in our notes, I have a whole list here of our steps. I'm going to give you, like how we had, isolate, split, and solve. I'm going to give you one of them for this. But if you like all the words, we have all the words. Because what we're doing is we are going to be solving radical equations algebraically today. And what that means we're going to do is we need to isolate the radical. So we're again going to start with isolate. Whoop. Yashki. I will send him right up. Thank you. Bye. Come here. You've got headphones, I can't hear me. I was expecting them to do an announcement. All right, so our first step is going to be to isolate the radical on one side. Then to get rid of our radical, we're going to do a power. Technically what we're doing is exponentiating, if you like the big words. We're going to isolate, we're going to use a power. And then we're going to finish solving. So isolate, power, solve. Or exponentiating. And we're going to practice this a bunch of times. Oh wait, we do have one more step that I didn't mention. We have to check. So put a check on the end. We have to check and make sure our solutions work. Since we're working with powers and things like that, we could wind up with extraneous solutions. So we need to make sure we check. So we're going to do isolate, power, solve, check. Okay, so we're going to start with a couple of simple ones. I'm going to write our little thing up here. We have our isolate. Power. Solve. Check. So our first one, we've got the square root of x is 3. My square root is already isolated. We love that. So done on isolate, check. Then we're going to use a power. What power am I going to use to get rid of a square root? 2. We're going to square it. Whatever it is, it's always going to be our index. So if I square the left-hand side, I'm going to square the right-hand side. My square and my square root cancel out, and we're left with our just x. And on the right, we have 3 squared, which is 9. And then to check it, you can like just type them into a calculator. All we care about is do we check it. So if I go the square root of 9, am I going to get 3? Yes. Perfect. We do the thing. Because sometimes we'll get weird answers. And that's how we catch that. But that one is like the simplest it's ever going to be. Because more often than not, we'll have something like the right-hand side where we have 2 square root of x minus 4 equals 0. So if I have something like 2 square root of x minus 4 equals 0, we've got to start with our isolate step. Means I need everything outside my square root to go to the other side of my equal sign. I need this chunk by itself. I need my square root all by itself. So everything outside that yellow box to go away. What do I need to do to get the everything outside that yellow box to go away? Add 4. I recommend starting with anything added or subtracted. Not saying it's the only way to go, but it gives you the lowest chance of fractioning. So now I have 2 square root of x equals 4. What do we need to do to get my square root by itself? Divide. We're going to divide by what? 2. So then we have the square root of x equals, oh, that was a divide, 4 divided by 2, which is 2. So now I have my absolute value isolated. Now we need to use a power to get rid of my square root. I'm going to take my index. Remember, the invisible index on a square root is a 2. That's what we use as our power. Whatever our index is what we use as our power, because that'll undo whatever root that is. So we wind up with x equals 4. Nope, that's not what I meant. There we go. So what we're going to do after this is we need to check it, which means I need to take this and put it back into the original equation and make sure it's exactly what we get. So an easy way to do that is to actually use our calculator. We had 2 times the square root of 4 minus 4. And we get 0. So typing these into the calculator is a lovely way to check. To make sure that we get whatever on this side is to equal what's on the right. Questions on the first 2 of these? Because we're going to do more. And they'll get crazier. Okay then. Next 2. So we've got the square root of 2x plus 5 equals 9. So this is our first one. And again, we're going to need to isolate. Pen's premature. Then we're going to use our power. Then we're going to solve. And we're going to check. So we've got to do all those steps. Isolate, power, solve, check. Put my word solve really close to the ceiling there. So looking at this first problem on the left, what are we going to do first to isolate? Subtract 5. Exactly right. Minus 5 on both sides. That's going to give us the square root of 2x equals 4. Do I need to do anything else to isolate it? We're going to do square next because it is isolated. The square root's all by itself. So my next step is to use my power. So I'm going to raise it to the power of my index. So the square root of 2x squared equals 4 squared. Whatever our index is what our power is. Because a square root and a square will cancel out. And we're left with 2x equals 4 squared, which is 16. What do I do to get x by itself to finish my solving? Divide by 2 on both sides. And that's going to give us that x equals what? 8. Yeah. X equals 8. And then we're going to go check it to double check that we did it right. So we're going to grab a calculator. And we're just going to type in the square root of 2 times 8, and I don't remember the problem, plus 5. And we got 9, which is exactly what we're supposed to get, so we did good. Go team. So we checked it. Boop, check. Okay, so we've got another one up here. I don't know that I gave us one that wouldn't check right. Let's see. So our first step is to isolate my absolute value. What do we need to do first? Subtract the 2. And we're left with our square root of 3x minus 5 equals 6 minus 2 gives us 4. What are we going to do next? We're going to do our power. We're going to square it. So we take whatever our index is and raise it to that power on both sides. My power and my square root are going to cancel out. That's the whole point of doing that, is to get my 3x minus 5. Oh, thank you, sir. My 3x minus 5 equals 16. And what are we going to do next? Add 5. Yeah, you got it. It's all good. We add 5. That's going to give me the 3x equals 21. I recommend strongly doing adding and subtracting before you're multiplying and dividing. If you do your multiplying and dividing first, you'll get a lot of fractions. It's not wrong. You can do it. It's absolutely fine. It just is significantly more fractiony. So if you do your adding and subtracting before you do multiplying and dividing, minimal risk of fractioning. You know we hate fractions. At least most of us do. So what are we going to do next? Divide by 3. So divide both sides by 3. And we get that x equals 7. So all that work for is 7. And then we're going to check it. So we're going to go to our calculator. And we're going to type in the square root of 3 times 7 plus 5 or minus 5? Can you tell? Minus 5 plus 2. Minus 5 plus 2. So we're going to check it. We still got 6, so we're good to go. That means we did it right. That's what a check is for. It's to make sure that we did it right and to make sure our answer is valid. Sorry, I didn't mean to jump ahead like that. I thought I had paused. Okay, we only have two more left. Because there's a couple of different ways we notate things. And I want to make sure that we've seen them. Because we've used these fraction exponents. Remember when we're looking at our fraction exponents, that's the same thing as our power over our index. So it's the same thing as an index here, x to the p. So our index is the denominator in the fraction. So if you don't like these fraction-y exponents, you can switch this around. Our index is 2, so this is a square root. We have the square root of 13x minus 4 plus 8 equals 8. And again, you can absolutely leave it as the fraction-y exponent. Works just fine. But just to remember what the fraction-y exponent means. Because this chunk is the square root part. So we need to isolate the 13x minus 4 first things first. So what's our first mathing step going to be? Subtract the 8. I knew they were going to make an announcement.
Pardon this interruption. We did testing continues this morning. We have 3 group testing in the morning in X214, T201, and X206. Students should go there now. Thank you.
I don't think anybody else is on the list for today. All right. So we've subtracted the 8 from both sides. What are we going to do to get rid of my square root? Power. We're going to square it. That's going to give me my 13x minus 4 equals, what is 10 squared? 100. I feel like I made this gross, but okay. What are we going to do to get this by itself? To figure out what x is? Add 4. So we have that 13x equals 104. And what do we do to get x by itself? Divide by 13. So we're going to come over here and we're going to do 104 divided by 13. And look at that, we get an 8. So we still got a decent answer. Your answers won't necessarily always be whole numbers. Sometimes they can be fractions. Sometimes they can be decimals. But it's not super common. Since we need to go back and check it, we usually give you whole numbers. So when we go back and check it, I'm going to go up to my original equation, where we're going to have 13 times 8 minus 4 to the power of the fraction 1/2. So I can make it look just like that. I can even use the fraction stuff. Plus 8. And I can make it look just like that whole expression at the beginning. And we get 18. And that's exactly what we were supposed to get. So we checked it, and we're good. We're going to do one more like this, okay? The check will come more into play tomorrow. So it's a good habit. Okay, so we've only done squares so far. It's the exact same process, even if it's a cube. So here we've got 4 times the quantity 2x plus 6 raised to the power of 1/3 minus 9 equals 3. So it's a bit of a beast. But like I said, this is the last one for today, so it's okay for it to be a little bit of a beast. Because our first step needs to be to isolate my root, isolate my radical. This chunk is the radical. So we need to get this piece all by itself. What do we need to remove first? I was going to say, if we do the 4, we can absolutely do that. It's not wrong. It's just significantly higher chance of fraction. Add 9 is going to be what I recommend. Like I said, you can absolutely divide by 4, but then you're going to have 9/4 and 3/4, and it's going to be a little bit gross. So we're going to add 9. That's going to give us 4 times our radical, which is our 2x plus 6 raised to the 1/3 power. Yeah, let me write your pass. I mean, this is our last one. If you want to wait for the end of this one, that might be good. What are we going to do next to get this radical by itself? Not going to root. Divide by 4. We need to get rid of the 4. That's going to leave us with our 2x plus 6 to the power of 1/3 equals 3. Remembering, this is a root when we have a fraction exponent. So what power do we need to raise it to get rid of that root? 3. If I raise it to a 1/3 power, look at what happens to that exponent. If we do this to the 3rd and to the 3rd, the 3 times 1/3, they cancel out. And we're left with just our 2x plus 6 equaling 3 to the 3rd. 3 to the 3rd being 27. So what are we going to do next? Minus 6. Well, that's a choice, but that's okay. I made a choice. So we have our 2x equals 21. Which means, what does x equal? 10.5. Yeah, 10.5. So sometimes we may get decimally answers. And that's okay. What we did here was divide by 2. We still need to check it. I was writing it down so we can actually remember what it is. So the way we're going to check it is we're going to go to our calculator. Number 4 times our quantity, 2 times our x, which is 10.5, plus 6 to the power of the fraction 1/3 minus 9. And we get 3, which is exactly what we had here. Okay, so the solving stuff, it just takes a little bit of getting used to, but it's not super different than the way we've solved previous chapters. Okay, so I'm going to pass out a homework for solving. This is our last homework of the chapter. Tomorrow you're going to want your computers, not a super ton, but we're going to do a little bit of graphing on the computer, just so we don't have to spend like 3 hours graphing stuff. So you might want your computer tomorrow. It doesn't work super great on your phones, but so the only one on here that involves anything of what we're doing tomorrow really is number 10, where we're solving by graphing. You can also solve it algebraically, but we're going to talk about what it means to solve it with graphing tomorrow. So we have a quiz on Friday, and this is the last homework of the section. Okay, so tomorrow I should have the review for you guys as well, if you want to pick it up a little early. That way we can work tomorrow, review Thursday, quiz Friday. It's kind of the vibe.